And we change at the weekend the clock. Okay, bye-bye.
Okay.
Good
Yes.
morning.
Okay. Yes. Hi, everyone. Good afternoon. And sorry for keeping you waiting so long. And greetings from Starry and the third Japan Solar Plus Energy Storage Virtual 2020, co-located with the second Japan Wind Energy again. So welcome everyone back to the afternoon session, and very glad to see you here again. And this is Starry, project producer of Leader Associates, and will continue to take the role as moderator of today's virtual conference for this afternoon session. So the conference recording of today's morning session has already been updated on the virtual platform schedule, and you can kindly find it if you need it. So, as for the speaker's presentation slides, we will share you the ones which is not so confidential and allowed by our speakers within next week, and with a link of the recording of the whole conference. And before we started, please allow me a few minutes to just cover a few housekeeping items. Yeah, you can find the conference agenda in this slide. And in the afternoon session, we will go through the asset management and microgrid innovative project and the key financing concerns in the Japan market. And I would also like to remind you that the 1-to-1 business match function, which you can find on the top menu, will be closed by tomorrow evening. So if you want to explore more networking connections, please find the person you want to build a relationship and click the add friend link to begin your chat. So at last, if the audience want to interact with our speakers, please raise your questions in the QA box. We will go through the questions after the panel discussion and after each speaker's presentation. So we really treasure this online opportunity that we can share and learn from each other. And now, without further ado, let's start with the first panel of the afternoon session. Welcome our first panel members, Yamazaki-san, Sakai-san, and Mr. Jung, to give us a discussion of ensure long-term health of project assets to maximize energy capture. And let me introduce our moderator, Masayuki Sakai-san, founder and CEO from CO2O, which is the independent solar plant total solution company in Japanese renewable energy market. CO2O suggests is a technical consulting and had already inspected about 2.3 gigawatt in Japan's solar power plants. So I will turn my microphone over to Sakai-san now and let Sakai-san to introduce our panelists. So, Sakai-san, would you mind turn on your camera and open your voice to the audience? Hi, Sakai-san.
Hi, I cannot switch on to the video button, so could you?
Yeah,
yeah,
sure.
By yourself. Can you see my handsome face?
Yeah.
Okay.
Yeah, really handsome.
Okay, thank you so much. Yeah. Thank you so much for introduction of our company and myself, Xiao-san. So our company CO2O is an independent operation and maintenance company, and not only operation and maintenance services, but also the due diligence or development support, asset management support of the solar power plant. And we provide a total solution services related of the technical of the solar power plant. And this time we are so excited about the this session, these topics, ensure long-term health of project assets to maximize energy capture. So this time, unfortunately, Mr. Yamazaki-san already have joined.
No, he will join in our later part of it.
Okay. So for the time being, we like to introduce Mr. John Hackbeth from Germany, probably, and he is a global head engineering and construction. He's in charge of the Sonetics, and yeah, I'm so happy to be able to discuss about these topics with him. So could you let him join of this session?
Yeah.
John-san, nice to meet you.
I cannot start my video. Nice to meet you.
Yeah.
Oh, yeah, we will turn on video from our side for you.
Okay.
No,
Yeah.
We can see your handsome face too. Yeah, thank you so much
you.
for coming.
Thank you, Konnichiwa. Thank you for the nice introduction.
So you're joining from Germany?
Yes, I joined from Germany.
Thank you so much.
Unfortunately, as we all know, COVID is limiting to be together. And this is the reason why we have a virtual event. But yes, I'm joining from Germany. You see my headsets here to have proper voice and video. Should I introduce a couple of minutes of my company?
Yeah, please go ahead of your company.
Yes.
And yourself.
Yeah. So we are since 7-8 years in Japan. Sonadix was founded 10 years ago. We celebrated this year our 10th anniversary. And we are now owned by institutional investors, which is advised by JP Morgan Asset Management. We are in 8 countries. At the end of this year, we will have 1.5 gigawatt own operational capacity, and we control more than 3 gigawatt of projects, which means control. We develop, but we have secured land, so it's not like it's on a green piece of paper. In Japan, we have plus 20 projects, so roughly more than 530 megawatts. However, only 250 will be at the end of the year constructed. So I really enjoy to come to Japan. We have normally 6 projects per year in construction. And that's the reason why I also since last year participated in these events, because we still would like to grow. And based on that, we are looking for projects partners who can support us in the grow. So buying operational assets, buying late stage development, and we develop our own self. And today we have more invested than 3.5 billion US dollar. And in general, we are in 8 countries and some continents, starting with Japan, Italy, Spain, France, the UK, but also in South Africa, Chile, and in Puerto Rico. In Chile, we are right now building our biggest plants, which is in Atacama Desert. It's 170 megawatt. It's like on 50 hectares or around 1,000 acres. And in Japan, we have some smaller projects, 2-3 megawatt, but the most of them are utility or mega solar, 30 to 50 megawatt project size.
Wow, thank you so much for introduction about your global company. So Johnson, so compare with other countries, could you tell me about your feeling about the Japanese market? What do you think about the Japanese solar power market?
It's very interesting, especially I see it from the technology point of view. The solar market, if you go back in other countries, 15, 20 years ago in Europe, solar started. But where you see today, we need to add batteries. Like look at, especially in America, solar plus storage is, you need to design like that. So I still believe like solar, floating, and even the combination solar with hydrogen, very attractive for our climate goals of the world. And Japan has a lot of consumption and a lot of possibilities to build more solar and use other technologies to be able to support the utilities and the stability of the grid with batteries, for example.
Yeah, I really think so. I guess this topic's theme is ensure long-term health of project asset to maximize energy capture. So probably already a lot of the speakers have talked about this kind of the topics, and probably to some extent, many audiences already have get bored to listen that such kind of the solar power market trend or movements or topics, but I guess we are now standing on the historical moment to change the paradigm shift. I mean, for example, the last week, Prime Minister Mr. Suga announced that until by the 2050, we Japanese government will achieve the net zero of the carbon dioxide zero. So this kind of the trend is very activated on to our market. And so Johnson, what do you think about this kind of the movement, historical movement of the solar power market or wind power market or renewable energy itself?
I think every industry needs support from the government.
Yep.
And this is part of our theme is the government needs to take care of a stable environment. I mean, I'm talking as an external, you can say not Japanese investor. And also for the Japanese investor, they would like to have stable, clear rules and regulation, which are hopefully not changing for the long-term investment. And we see this in every country. We need goals that technology is pushed and supported, that we can have a breakthrough. If you look 20 years ago back, if we would not have a high feed-in tariff, solar would not be coming to mass production and being getting cheaper and cheaper every quarter.
I really think so. Solar power market is one of the most, driving market of the, to change these movements. And probably a lot of the people demands, solar power market player needed to be more stable, more stabilizes this market and this business model itself. And actually, in Japanese market, the FIT system has been over, and it is said the FIT system is installed from now, but we don't know how do we monetize or how do we make a good business model using FIT. So could you tell me about your viewpoint? What do you think of the solar power market from now on?
I mean, I think if you compare to other markets, the feed-in tariff goes down, but also the government and the regulation took care of private PPAs and of new revenue streams.
Yep.
So that's what I tried to say with solar and storage. In a lot of markets, you have the possibility to get more revenues with offering more services to the grid, like frequency control, voltage control, and other things. So if the regulation supports additional services and revenue streams, PV will continue. On the other way, we should not forget Japan, as compared to other markets. Also, we are very often in mountains, so the construction of a PV plant is expensive.
I see. So,
compared to other markets, if you go to a desert, I mean, you have no trees, no slopes, no retention ponds, because it's only one day per year raining, and I have 365 days of sunshine. Yeah. It's a little bit different than you go to Japan, where typhoons are coming, heavy rain, and you need to protect the environment, the nature, and the people, the community around. So retention ponds, drainage, it's a very expensive business. You can do everything. I'm an engineer. So for me, there's no limit in technology. It's just a limitation it will bring on the required money.
I see. I agree with your opinion. And actually, so technical issue is a big point. And actually, we are operational maintenance company, but we are due diligence a lot of the project. And unfortunately, the Japanese project has a lot of the lack of the problem, lack of the civil work or drain system problem, or not only electric part, but also the other problem happened in the Japanese in the project. And actually, mounting system strengths or drain system problem or civil work problem. There are a lot of the critical issue happened in the several projects, and we try to renovate such kind of the civil work construction program by our company. And so I guess technical issues is one of the very important key to stabilize this business model in this market. And unfortunately, the asset manager or investor not so have a full knowledge or have a lot of the experience of such kind of the technical issue. And probably the special technical consultant or third party is a very essential in this market, in my opinion. So how do we stabilize this kind of the technical program of the solar power plant? Because this market is a very immature, and it's a early market, and nobody knows about how do we control the solar plant for 20 years or more. So could you give me advice of your viewpoint? How do we manage this kind of the technical issues?
Yeah, I mean, for us as an investor,
Yeah.
We try to get experts on board. So let's say in other parts of the world, we have the possibility of 20 years of experience, Japan not. But therefore, we try to bring expertise in. And what is for me very important is our company business model is long-term ownership. So we are not planning to sell the asset after 2, 3, 4, 5 years, whatever the age is. We want to have it long-term. So our perspective doing the development and construction is long-term profit and of the asset. So which means also we sometimes need to spend more capex and more investment upfront. So based on this, we rely heavily on third party. You know, Japan, you need to have your partners on, because in Japan is also a shortage of manpower, and of course language and written and spoken barrier if you get experts from abroad over. But we also try to see it in this way. The quality and the long-term profit of the plant begins with the design. Even choosing the site, but then design. We have a heavy pre-qualification of all equipment providers and checking regular the market if any racking panel has an issue. And based on that, we hope and we believe, and we see the last 7 years since I'm with the company, that during the operation, we will have less problems with panels and other things. And just to give you an example, we also had a project in Puerto Rico. It's a small island in the Caribbean. And 2 years ago, we had 2 hurricanes, and one was Irma. When it hit Puerto Rico, when it hit the site, we had a category 4 hurricane over our PV plant. And we lost a very limited amount of panels. Most of the 5,000 panels we lost were due to the fact that the debris, the coconuts, the stones fall from the wind on the panels and damage them, but they were not flown away. So which means we designed this PV plant for hurricane, that it can sustain the wind load, the rain, and of course you need to select a panel which is mechanical stress resistance, and there are not so many on the market at that time. So all of this was taken care, because we know every year in the middle of the Caribbean are some hurricanes, and maybe every couple of years we will get one. And how do we protect our asset? Or if we have a hurricane, how quick we are back to operation.
Wow. Yeah, well, it's a very surprising story. So, thinking about the long-term stabilization of the solar project, I guess in our company's opinion, asset management system is essential. And our company, CO2, is only service provider which can be a certified of the ISO 55001, and ISO 55001 is a asset management system guide. And we are only service provider which can be certificated of this official asset management system. And we are learning how do we manage, how do we maximize asset management system into a project. And thinking about the asset management, there is 3 components: performance, risks, and cost. So these 3 items is a very different direction. But how do we manage? How do we make a balance between these 3 factors? Is asset management systems key? And unfortunately, in terms of the solar project, a lot of the asset manager or investor just think about the performance or cost itself. Cost reduction pressure is very big, but unfortunately, there are lack of the risk factors. And so as you said, that solar power system has a lot of the potential of the risks. For example, disaster is, as you said, it's a very big critical issue. And how do we calculate this kind of the risks into our project? So probably, as you know, the asset manager finally they need to calculate the cash flow, and how do they maximize the risks? How do they minimize the risks? How do they maximize the cash flow? But how do we think about the risk itself is a key to think about the solar power project. And, so risk management is the most important critical, essential things to stabilize our solar project in our company. So, and Japan is a country with many disasters, and Puerto Rico is one of the country, but probably Japan is also same country to face a lot of the disaster, typhoon, earthquake, or tsunami. So could you tell me about your prevention of such kind of disaster in your experience, in your career?
Yeah, I mean, we didn't have the tsunami, but yes, typhoon over our sites. So before our asset manager are looking, of course, at the news to see if a typhoon is coming and where the possible route is. And then if this is coming close to our assets, we are preparing the assets. Like, you shut them down, you make them stable, first of all, that no person is getting hurt or injured. And this is number one. This is our commitment to the society, that first we need to take care of the people, and then we try to take next of the environment, what we can do, like like equipment, machinery, that they know, like a tank for grass cutting machine is not open and can fly around, and the oil or the gasoline is spilled. So we prepare, and then we carefully online watch our assets. And of course, when you have typhoon, or depending where you build, we try to do the proper pre-design with drainage, retention ponds, slopes, also proper grassing levels to protect that. This is again very important, the engineering design. Of course, you never know how large, intense a hurricane, typhoon, tsunami is. You take the guidance, the safety factors, the 50 or 100 or 200 year event into consideration, which therefore, if you go on some of our sites, thanks of the prefectures, we have immense retention ponds and trying to protect the society, which is, yes, a cost factor, but we should also not forget, if you are 30 years with the asset next to the neighbors, this is a long-term relationship. We are having an asset there, and on the other way, we have neighbors, and we need to take care that from our asset, no neighbors are in danger.
I see. So, in terms of the asset management system, I remember the term of the trilemma, performance, cost, and risks. These three factors is trilemma. And, unfortunately, a lot of the investors just think about the performance or cost itself, and we may forget about the potential risk or risk itself. So how do we manage? How do we reconsider about this kind of risk factor into our project is a key to make a successful of our project.
Yeah. And then we do risk management and with the typical risk tools from the beginning of the project. Mm-hmm. Development has risk, construction has risk, and asset management risks. And we should not forget, you can also get insurances for some risks, but some of the risks have a much more higher monetary impact on the asset. So it's better to take care before with low and less maintenance and money and cost and time of the asset manager than when the event is happening. And then maybe for 2-3 years, your asset is, if a full hurricane comes over and you didn't build it accordingly, or typhoon, and it's everything destroyed, it takes you a year to demolish and then a couple of 1 or 2 years to rebuild it. So how much interruption you will have and loss of revenue. So it's better for us, this is what we strongly believe, to take during the lifetime proper risk management. It's very important.
I see. So
which also included monitoring the regulation framework, the change, because every change might also have a big impact, as we have seen in Japan with wheeling charging, etc. Demolition charges coming later, reactive, has an impact on the asset performance.
I see. So as a one-day player, I'd like to ask about the key element of the selection of the asset management company or operation and maintenance company. So as an IPP or as an investor, so could you tell me about the most important key element to select the good asset management company, a good operation maintenance company. Could you tell me about your opinion?
Of course. For us, we don't want to have an asset management company which is passive. We want an active partner, and we are trying to look proactively into our assets. So it's not like there is an issue and then it's been fixed overnight. We would like to have predictive maintenance, preventive, and not like it happened, now I need to fix it. So there's enough artificial intelligence, computer system, digitalization. There's a lot of buzzwords flying around. You get so many data from our systems where the asset management system can support the asset management company to make decisions and saying, look, the fan of the inverter is getting in 2 months broken. Should we wait before it's breaking and then the inverter shuts down? And if you have a 3 megawatt inverter, then you lose 3 megawatt, or you do it in the time before it is predicted to happen, to have a continuous operation.
I see. So at last, Mr. Yamazaki-san will join this session. So Shao-san, could you open his channel to join our session?
Oh, sorry. He is rejoining right now, and maybe about 5 or 10 minutes later.
Okay. Okay.
Sorry.
Okay. So yeah, Johnson, thank you so much. So it's a very interesting opinion, and actually, as operation maintenance service provider, cost reduction pressure is so huge recently. So especially Japanese FIT system is over, and actually the project itself is very difficult to control the return, and so OPEX, CAPEX pressure, cost reduction pressure is so huge to the operation and maintenance company or asset management company. And how do we face at this kind of difficulties is one of the important issue to think about long-term stable business model.
Yeah, I can totally agree, and I think something what you cannot control, but only the, let's say, the owner or the person who's constructing the power plant. This is also what we do is doing engineering construction. One thing is you're focused on CAPEX, but we try to focus on levelized cost of electricity over the 30 years lifetime of the plant. And this means also which kind of structure you choose. Or do you spend some more money for the galvanization, plus streets, road distances, that you can even do maintenance. Can you imagine you're on the slope, you have half a meter between the rows. How do you want to change if there's a massive problem with structure, panels, inverter? How do you want to go there? So we need to have streets, ways, rows that workers, machine can go there to be able to quickly change equipment.
Yeah, I see. So in terms of the operation and maintenance cost, most of the cost is consists of the labor cost, and it's very difficult to reduce the cost itself. Especially Japanese labor cost is very expensive compared with other countries. And I guess thinking about the cost reduction, we need to make use of the technologies. These days DX, digital transformation, or technical, IT revolution, or AI, or drone technology. So such kind of the technology can cover these kind of the cost reduction issues. So could you tell me about your opinion? How do you make use of such kind of the technology to of your project of the maintenance services?
Yeah, I mean, I can tell you, yes, we do. So one thing is, of course, we have a SCADA system, and then the data will be analyzed. So as you said, digital transformation, and I mentioned before, artificial intelligence, machine learning. So there's fantastic products out on the market who gives a lot of analysis and support that you need less manpower to do this by themselves. On top is also how much data you're gathering. It's again a design point of view. I mean, I remember years ago, you could get a central inverter with or without string monitoring. So if you do it without, you have your inverter monitoring. If you go to the string level, costs more, but then which string is really performing well, and you can compare. So if you take an asset with or without string monitoring, then you might have more work when you have to find the mistake, the fault directly, and to fix it when you are pointed directly to the point, to the road, to the, I mean, really with mapped PV plant to the exact location within 5 meters, you will be much more quicker at the point of fault, can replace it, repair it, and be gone from the site to the next issue. So we see systems with tablets. We are also trying to do more automatic drone stuff. So this is part of my field and function within Sonadix, that I have the pleasure to look into new technologies. So also in some places, robots to clean, drone, then new measures to measure quicker, faster. Because it's if you go in the past on the PV plant for IV curve measurements manually, you do 5 to 10% a year, cost you 2-3 weeks work of an external party, or can you do it somehow automatically?
I see.
Computer, machine. I don't want to say robots. In this direction to repeated tasks, do it by the machine.
I see. On the other hand, so as the operation and maintenance provider, actual services, actual frontline services is provided by chief electrical engineer. And unfortunately, the chief electrical engineer's generation is quite old, over 60s or 70s. And actually, I guess it is very difficult to adjust for such elderly to adapt the new technology, DX, transformation. So frankly speaking, recently the government asked us to use such kind of the DX into solar power operation and maintenance services. And could you propose such kind of the new business model or new ideas to actual site maintenance, actual operational services of AI or IoT, but the chief electrical engineer cannot understand such kind of the cutting edge technology. So this is one of the big issue to transfer to such a new era for Japanese operation maintenance pre-existing services. That is our real opinion. Yeah.
I mean, the chief electrical engineer is specific for Japan.
Yeah.
You don't have this kind of setting in the 7 other countries we operate.
Yeah.
So it's not required to have like one chief electrical engineer for a bigger solar site. In some countries where you have similar approach, at least one chief electrical engineer can handle various sites when they are like in a 2 hours radio. Then you also can limit the number of chief electrical engineers required. But of course, where everything is, I found out today that my kids are with some computer gimmicks much more better than I'm doing, and I'm not 60, 70, but moving there. So I think we all face the time that we need to be on the technology edge to see. And of course, for the a little bit other older generation, like my parents, which is 82, they are interested in new technologies, but need more time. So it's more how you build a bridge. So for us, we have the new technology there for the data center, and the chief electrical engineer locally is getting his information. So we try to build a bridge between the fresh IT expert from university compared to the vast 40 years plus experience, which a young computer guy never can have. So we try to build the bridge, the balance. So build on the experience of the chief electrical engineer, but then get the kind of computer expert in, and both together, it's a team where you are good there, somebody else is good in another field, and together you are strong to be successful.
Absolutely, I think so. Yeah. So Don-san, so you already have prepared several slides or documents to explain about your idea. So is it okay to share such kind of documents or slide?
I'm fine. This is just a quick summary. Of course, I'm fine. I even uploaded them. So I don't know if the conference, they share it or I should share it. Either way.
Yeah. So, John, you can also share from your screen for the audience.
Okay, I will share with my screen.
Yeah, please.
Because I have 3 screens at my home office, so you should see this, I hope. I share now. I hope you share my screen, Sonetics. Sakai-san, do you see my screen?
Yeah, I can see your screen. Yeah, thank you so much.
Good. Thanks. So just some going through stuff. As you see, a nice picture from a mega solar plant in Japan on the slide 2. This is in Oita Prefecture, 38.7 megawatt. So it's one of our first being commissioned and COD this year in March. Built by a Japanese EPC contractor. Fantastic quality. So if you go on slide 3, you see some of our operating plans. You see 270 in France, 380 in Spain, 240 in Italy. From our pipeline, 534 in Japan, South Africa, Chile, and USA. If I go further, maybe the overview, how do we see the long-term health of projects and assets? So for us, long-term health and project assets means 2 things: that the asset is providing a stable financial revenue stream. Mm-hmm. And of course, the second part is what we discussed before, the technical quality of the asset. So that we can have limited resources, time and money spent during the lifetime to the asset for repairs, refurbishments, and other things. Because also internal management of assets under stress, it takes a lot of management time and time of the staff away, and we would like to focus on growth. So this is the 2 main things: the quality control assurance during the complete life cycles, especially during construction. We always believe try to solve the mistakes in the beginning, so not at the end. So if it's done, it's more costly than you do it in the beginning, doing design, engineering, construction, equipment choice, quality assurance, going to factories. It's extensive work and cost associations, because I also worked in the past at other companies. And if you look at the total investor perspective, give me the key, and no one does quality assurance. The asset has normally a different quality. So we do extensive quality checks from panel racking, inverters, and main equipment. I don't want to name all. So we go to manufacturers, or send third parties, and also during construction, we do the same. We have site managers. We come with experts to check the different part of the works, that we get a high assets and quality in. So this is slide 5 as a summary, testing in different stages, as I mentioned before. And of course, later during the assets, you have the IV measurement, as you most probably know, electro EL images, checks, visual inspection, modules, components, integrity, and of port. This is partly done in the past manually. There are coming more and more technologies out that this is done more, let's say, with neo technologies. But also, before you come to that asset, just look at the last bullet. You can say loading of modules into containers. Even when the containers arrive, we check the package, because sometimes micro cracks and other stuff, depending on the roads, on the transports, things are happening. And I can tell you, I by myself was 18 years ago on a project in Africa, and there we had a big transformer. And what happened during transport, the transformer was falling on the quay from the ship by deloading, and was internally damaged. But no one said anything. They transported to the site. So at the end, at site, by filling the oil in the transformer, we saw that it was leaking out. So which means that we needed a new transformer, 14 months of production and 6 months of shipping. So we lost 20. we lost 20 months of project connection time, which of course you need more people, it's costly, and it's no fun. And instead of seeing this on the Haber or even actively managing this to say, look, there's something happened, we need to test now and recheck the equipment. So it's very important for us. As I mentioned on slide 6, design and construction. So the choice of equipment, depending on the site, you take in the world, and I say in the world, string inverters, you take central inverters, there are different MPP trackers. So you have different functions, and this I'm talking like apps in the equipment. And this is sometimes it's the same price, but the app is making the difference of reduced power and manpower you need during the OPEX and operation. You then we talk with our asset management and O&M team, which we have in different parts of the world, their learnings, and get it back into engineering to be better. We apply latest technologies, bifacial tracker, true capture. It's again a software from some tracking manufacturers that they are improving the yield. So one thing is by this OPEX, CAPEX reduction, but the other way, how can we improve the production of the site? So with better equipment. And then, as you saw and we discussed before, critical for long-term success is oversight of the operations. So every day we and our partners looking, we have a global view of all our assets. So our competence center is in UK for the time being. So they get now from 1.4 gigawatt all the data's in, and this is plans from today 86 to down to even a couple of 100 kilowatts, because we also own some rooftops. Soon, luckily, we get a 170 megawatt site in. And if you look our battery system, which we have in Puerto Rico, due to the Caribbean and the clouds coming very fast, we are getting there over 30,000 signals a month. So which have then from there, we try to calculate how much we are using the batteries, what is the impact, degradation, and performance, future performance of the things. We talked about, you said it so nice, digitalization. I called it here big data. I think we all have so many data, and still we are the beginner of understanding how we can use them in a better way. This was like a very short summary of my points. I'm happy if everyone who wants to contact me, ask further questions, please send me an email. A pleasure to give you some more insights.
Okay, thank you so much, John-san. So we still have 10 minutes remained, and Xiao-san, so if there are any questions from audience we'd like to answer, if there are any questions we already have gotten?
So far there's no questions from the audience, and because I think we have like talked comprehensively during your presentation as well. There is like 10 more minutes, and so we'd like to ask the audience whether there is any other questions you would like to know. And okay, yeah, sure. So there is one question from Eric. Yeah. So it is for John. So what are your exact assumptions about the post-FIT pricing?
That's a fantastic question. Unfortunately, I cannot share this with you. This is confidential. I'm so sorry. I mean, we are trying. Sorry, if someone asked also for the config. So we are trying to be on the market, being also with the Japanese Solar Association, understanding the trend. But on the other way, we are also building in other parts on grid parity, on private PPAs, on merchandise, so spot price market. So we are always constantly trying to improve and adjust to the market, and we believe Japan is still a big growth market and has a fantastic how to say, a future for us. And
thank you.
Sorry for that.
Yes, so and yes, there is some audience would like to know your email address and would like to know whether you can share your PPT slides with the contact details again.
Yeah, I mean, the slides are uploaded. I don't know if you for sharing. I don't know how to share via the system to the audience, but I'm happy to share the slides. I uploaded them yesterday into the system, and of course I can go back to screen sharing, and then for people to take the email address. But I think over the conference about you can share my.
Yes, yeah, sure. We will also share your question as the audience, and the audience contact with who raise the questions for you.
Yeah. So please, for the audience, and the slides I shared yesterday, I uploaded to the conference platform.
Yeah, sure.
But again, if someone sends me an email, I'm happy to share this too, but it's maybe easier via the conference, then it's maybe easier.
Yeah, sure. And so I would like to check again whether there is any other questions Sakai-san wants to ask, or whether Sakai-san wanted to introduce more of CO2O or your current projects.
Okay. So our company is operation and maintenance service provider, and what strength is the due diligence itself. So it's already have over 3 gigawatt of the Japanese market. We already have real actual site due diligence. And as you know, recently the secondary market is very vivid, and there are a lot of the asset manager or investors like ask us to check the quality of the project, and not only technical issue, but also the legal issue or financial issue. We like to confirm whether this project is suitable for invest or not, so we can report. Of course, our strength is a technical report, but the total due diligence we can be empowered. That is our company's recent topics. And also, operation and maintenance service is expanding dramatically. So recently, is 500 megawatt we already have ordered, and probably until the next year, probably over 1 gigawatt project we can be empowered. That is our operation and maintenance budget, and probably this market is only a few players can dominate the operation and maintenance services. So we can be remain of such kind of the top ranked operation and maintenance company, and we are now aiming at the IPO in near future. So that is our company's very recent topics to introduce our company. Yamazaki-san, Atlas can join. Yamazaki-san, it's too late to join. It's already finished. But could you introduce your company or yourself? Shao-san, it is already muted, and could you change?
Yes, we will open the microphone of Yamazaki-san.
And I will stop sharing the screen, okay?
Okay, thank you, John.
You did already. Sorry.
Atlas Yamazaki-san will join. Yeah, okay, please speak on.
So Yamazaki-san, you have to open your microphone.
Can you hear me?
Yeah, Atlas, welcome. Welcome to our session. It's only 5 minutes remain. Yeah, could you concisely introduce your opinion or your ideas?
Yeah, actually, so we are developing and also managing assets, managing money, and managing property, all the renewables, particularly solar and also wind and the other the project. Okay, maybe on my back, you could see that this is Japan so far is the biggest completed the mega solar, and which is located in Okayama Prefecture called Setouchi City. And but this is a very much difficult project in terms of not only the development, construction, but also the places at 2 meters lower than the sea level. And also that it was formerly, it was just sea, bay, and then converted it as a salination field to make salt, then converted it into the mega solar. So sunlight produces salt that 60 years ago. Now they are producing that electric power. So obviously that this is very much salty, salinated area still, so that are very difficult to maintain. And also that natural disaster is a really big issue. So that at the time of that actually this is maybe the first and maybe still the biggest that auction project. The 30 companies that showed interest, and 8 companies joined the public auction, and 4 companies selected as shortlisted, and we were chosen. So we particularly put a lot of the financial resources and also the technological and also development, something that needed to divide something that's innovative. So there are the natural disasters, there are mainly 2 risks. One is the earthquake and tsunami. And fortunately, the tsunami, based upon the research, tsunami is not a big risk, but still the earthquake could hit. Particularly this was actually the border here. It was just an embankment or some bank. So we spent $40 million that asked Shimizu construction company to divide the new subcontinent to the 40 meters long and also 40 meters deep and so 2 kilometers long that was very specially made. The some kind of steel structure which would prevent the embankment falls, but also to be some kind of transparent to make the water flow in and out. So, and the second thing is that we put a lot of resources for natural environmental protection. So we devoted and we gave up 75 hectares of land to protect the natural the species, particularly the so-called harrier. That is protected the endangered species of the bird. So we devoted 75 million to protect that bird. And also that we spent $10 million to make that for the dredging, and also that renew the pump. So these are mainly so it really worked well when 2 years ago there was a big flood in that area. So that's what we been doing, and still it's a lot of challenge to in terms of the cost management, and also that not only but for the natural disaster, but also that some kind of community, and there are many different kinds of stakeholders coming to this site, so very regularly. So we are doing a lot of the public relations, working closely with the city government who is the owner, and so that's our work, and has been, I think that we believe that we have been evaluated very highly, and also that by the, of course, the equity owner and also the lenders and also the community. So this is just our basic philosophy to make that to the area and also local community as client, to protect their interest and also their lives, and also that more a little bit broadly than nature and the area. So that is the way. Of course, it could be that costly, but sometimes we need to think about that how we can. But because of that we got a very strong support from the community. So the development and construction period was shortened by 1 year. So it actually created a lot of some kind of the profit opportunity for us. So that's the way how we develop our project. So going forward. So
okay, thank you so much, Imazaki-san.
Thank you very much.
Yeah, thank you so much. So Shao-san, time is over, and is there anything we need to stop our session?
Sure. Yes, for the final sector, so would you mind like to address like each person 1 or 2 minute conclusion of this panel discussion and the messages you want to deliver to the audience?
Okay, Joe-san, please.
Yes. For me, the quality and revenue stream of the PV assets depends on the beginning of the project up to the end, so the complete life cycles. So we need to take care of design, equipment, and to stress it, what Sakai-san said before, we need the proper partner also to manage the asset to be successful and have a constant revenue stream. Thank you very much.
Thank you very much. Yabuzaki-san, is there any comments?
Sorry that coming late. First of all, so thank you very much for me to let me join at the final moment. So thank you very much for this opportunity.
Okay, thank you. So,
Thank you, Sakai-san.
okay, so we are now standing on the historical moment to change the paradigm shift of the renewable energy. So, as a whole, you know, we can change to the new market, and probably we'd like to fight against the obstacles, but probably we will overcome the difficulties, and you know, we can stabilize this business model or this market forever. Yeah, I'm so looking forward to doing business with each other, and we'd like to find out good partners. Thank you so much, John-san, Yamazaki-san. Thanks a lot. Yeah.
Yeah, thank you so much for joining. Thank you for sparing the time.
Thank you so much, and have a nice day. Bye.
And thank you a lot for the.
You're muted now.
Oh, sorry. Yeah, thank you. Thank you so much for sparing the time. And thank you so much for joining the panel discussion. And later on, we will move to our next sector, and it is for the innovative project case study. And let me introduce our next presenter, Daisuke-san. And besides asset management during the post-FIT time, more and more C&I rooftop projects has gained market attention. So Mr. Daisuke-san, project leader of OES from Sony CSL, will give us a presentation about the microgrid for residential. And Daisuke-san has joined the Sony Corporation in an electric engineer in 2002. And since 2014, he has been part of Sony CSL and be part of the development to peer-to-peer power interchange software, which can realize local production and local consumption power systems. It has built the DC microgrid for residential, which is connecting the 19 houses in Okinawa, Japan. And later, he will introduce this project in details for you. And so, Daisuke-san, can you, share your screen and yes, your voice. Sorry, can you like turn on your microphone because we can't hear you right now?
Can you hear my voice?
Yes, yes.
Okay,
yes.
okay. So can I start my presentation?
Yes, please share your screen with us.
Yeah, thank you for introduction. And I will share my screen. Yeah, can you see the screen? Okay, I will start my presentation. My name is Daisuke Kawamoto from Sony Computer Science Laboratories. And at first, thank you for giving us a great opportunity today. And I'm happy if I can give some useful information for you in this presentation. And today's topic is these four. At first, I will explain what we are doing in Sony Computer Science Laboratories. And then I will introduce our DC microgrid, which are using IoT technology for energy system. And then I will share some experiment results which we obtained from 6 years operation. And lastly, I will share our future plan to realize sustainable energy society. And first, what we are doing in Sony Computer Science Laboratories, company introduction. So Sony Computer Science Laboratories is one of the Sony's laboratories. And the research policy is think extreme and act beyond borders. And research areas are now, there are three major research areas. One is global agenda, one is cybernetic intelligence, and one is human augmentation. And our research area is not limited to Sony's business domain. For example, energy or agriculture is very hard to imagine from Sony's business, but because our goal or purpose of our laboratories is to contribute to the society or the humanity, so our research topic is not limited to Sony's business and the research output as well. And today, I will explain the energy project in Sony Computer Science Laboratories. And here is Open Energy System OES project history. We started this project around 10 years ago. At first, we start from the off-grid area. In 2010, we did the Ghana public viewing because in 2010, there was a World Cup, a soccer World Cup, and Ghana joined the World Cup. But the people in Ghana, especially who live in off-grid area, cannot watch their national team's game. So we bring off-grid system, which consists by PV panel and battery, and bring it and did public viewing to watch the World Cup game in Ghana. And then we also do a feasibility study, which bring a solar home system to off-grid area and study if it can improve their lifestyles. And from 2014, we have started the DC microgrid project in Okinawa, Japan, and also installed DC microgrid in other university. And now we are trying to deploy this technology to realize energy sharing society. And there are some core technologies, so I will explain later. And next topic is DC microgrid in Okinawa. This is houses which we install our system. It's a very beautiful place. Here is an overview of microgrid in Okinawa. We have a joint research with Okinawa Institute of Science and Technology Graduated University, which called OISD. And thanks to OISD, we installed DC microgrid, which connects 19 faculty houses in this university. These pictures are so. And we put the battery system in every houses and connect these battery systems by DC microgrid to share the energy in the community. And this system is installed in 2014, and it is operating for around 6 years, and almost 40% of the energy is supplied from the renewable. Oh, sorry. And next, sorry, it's not working. Sorry, it's not working. But this is the energy exchange movie. Oh, sorry, please wait a minute. Okay. Yeah, this is what we done in Okinawa. Each box shows battery in each house. So there are 19 houses, so there are 19 batteries in this picture. And this green area shows the battery level, how much battery inside, how much energy inside the battery. For example, this one is a lot of battery, but this one is a bit lower battery level. So this one sends the energy to this one. This small circle shows the energy flow of the system. And as you can see that the energy is sharing by peer-to-peer. This house shared to this house shared to this house, and this house shared to this house. This peer-to-peer energy exchange is it's a physical peer-to-peer and not the virtual one. And this physical peer-to-peer is the key technology of our system. And also the residents can see this display, and they can know that how much energy is in their house and how much energy is in the community. And we are also aim to change the behavior of users in this system. And next is the microgrid information. First, the location is in the Okinawa, one of the southern island of Japan. It's in the Okinawa's Onna village, which is almost 1 hour from the international airport of Okinawa. And size of the grid is almost 300 meters, the 90 houses in these 300-meter areas. And here is the system structure of one house. Each house, so each house has a PV panel and battery, and they supply the energy from the PV panel to their house. And the house appliances is AC, so inverter is used to invert the DC voltage to AC and supply to the appliances. But anyway, they are work by standalone system by their own PV and battery. And 90 houses are connected by using a DC grid and communication line. And if a house becomes a shortage of energy, then they request other house to exchange the energy. And if that request is accepted by that house, it makes a pair and share the energy. And by the peer-to-peer energy exchange. And by sharing the energy, this system maximizes the self-sufficiency and maximize the PV generation in the community. And here are the equipment which installed for each house. Each house put the PV panels. It depends on the house, but we put 2.8 kilowatt or 4.2 kilowatt to each house. And there is energy storage system for every house, and the distribution board, which are supply the power from this energy storage system. And here is equipment inside the energy storage system. It consists of these parts: autonomous control unit and DC-DC converter, PV charger, battery module, and DC-AC inverter. And the key module is autonomous control unit. We are using BeagleBone Black, which is a Linux board. And this Linux board monitors the system and checks the battery level of the house or the energy storage system. And if the battery becomes shortage, then it controls the DC-DC converter to exchange energy between the houses. And these energy storages in each houses are connected by using a 350 volt DC grid lines, and the communication lines are also wired parallel. And here is information about the regulation. At first, we did not apply or is not required for the grid interconnection application because our system, if the PV generation is used within the community and there is no feeding to the main grid, so we don't need to apply for grid interconnection. And second is a private electric facility. We have to apply this one because the total amount of the PV is exceeds 50 kilowatts by total 90 houses PV. So we have to apply for the private electric facility. And there is an administrator in Okinawa. And next is experiment result. This is a control room we made in Tokyo, and we are monitoring remote monitoring the Okinawa system in Tokyo, and also collecting the data for 6 years operation. And I will show some of them today. And here is the concept of our system. Why exchange energy is because there is demand is different for each house in the community. The energy that energy imbalances can be leveled over the community by exchange the energy between houses. And here is real energy consumption data in 19 houses. This x-axis A, B, C to S shows 19 houses, and the y-axis shows the average energy consumption for each house. And this is a box plot, and please see the red line of each box. It shows a middle value of each house energy consumption. For example, house A is consuming almost 750 watt for usual, and house B is consuming 500 watt, and house C is 1000 watt. So there are very big difference for the energy consumption in 19 houses. So if the energy imbalance can be absorbed within the community by doing the energy exchange. And here is the system performance of the system. We use the self-sufficiency ratio for the evaluation, which means that this number this ratio shows how much renewable or PV generation is supplied for the system. And we did the simulation for two cases, blue and green. And for both plots, both lines, dot line shows a standalone case, which shows no exchange case. And the solid line shows energy exchange case. So please see the difference between the dot line and the solid line. It's almost 5 to 10% improvement or difference can be done by the energy exchange, and it means that energy exchange can increase the PV generation by 5 to 10%. And next is the energy exchange strategy. We are using state of charge SOC target energy exchange, and SOC means how much energy is remaining in the battery. For example, if SOC is 100%, it means the battery is fully charged. And if SOC is 0%, it means that the battery is empty. And we make the SOC target for each house depending on the consumption or demand in the house. And the exchange strategy is to execute it to reach to that SOC target. For example, if you set the SOC target to 50%, and if the real battery SOC level is higher than that target, it will discharge the energy. And if you set, for example, 50% and the real battery SOC is lower than the target, it will make the charge request. That is the energy exchange strategy for this system. And we did some study to optimize the energy exchange strategy. The first one is using a charging price of battery. Here we use the average price of energy in the battery charged from a few sources. For example, if the battery is charged from PV panel, it is set to free, means 0 cent. And if you charge from the AC or the main grid, it will set to 20 cents. And the average price of the energy in the battery is recorded. And that information is used to make the energy exchange request. This is a calculation, and the right side is a table which we use in the simulation. It uses both battery SOC level and the price information for the energy exchange. And the price, this BP shows the battery price information, and here is a battery SOC level. And the battery SOC level, when the battery SOC level is lower, then the battery price is set to higher value because it's more urgent case to exchange the energy. And we did the simulation by adding the price information for the exchange. And as a result, it can increase the PV generation by 10% by reducing the inefficient energy exchange. And yeah, it showed that it's very interesting result, and it showed that the price information is very important. And it can also improve the performance of the system. And second study is we use a prediction to make the energy exchange strategy. Here we use LSTM, one of the machine learning technique, to predict the future battery SOC. It is predicted from the previous consumption and previous generation. And we predict the future battery SOC and check if there is a surplus. Surplus means that if the battery becomes full or 100%, then the PV cannot generate anymore. And in that case, surplus will happen. So if surplus will happen, we make the energy exchange strategy to discharge the energy before it becomes full. And we also did a simulation for this study. And left side is the original case, and the right side is using the prediction. And this side, orange area size shows the surplus energy amount of surplus energy. And original one is like this, and this right side reduces the surplus energy by doing energy exchange before it becomes full. It's not zero, but it's improving. And it can, by reducing the surplus energy, it can increase the PV generation. And this prediction method is also effective to improve the system performance. And we are also interested for the battery lifetime, that how can energy exchange improve battery lifetime? And we focus on two parameters for this study. One is a full charge duration, and one is cycle count. And by doing the energy exchange, these two parameters has a bad effect for the battery lifetime. And by doing the energy exchange, we can reduce or decrease the full charge duration because we discharge the battery energy before it comes full. So the energy exchange has a positive impact for full charge duration. On the other hand, energy exchange increases the cycle count. And now we are investigating what kind of energy exchange can improve battery lifetime. And actually in Okinawa, it's operating for 6 years, and the battery cycle count is almost 900 times for now, but it is showing still showing a good performance. Yeah. And we also did some user interview, and they show positive feeling for our system. And yeah, and I will explain a bit about the technology of our system. The key technologies are two. One is autonomous distributed control and one is active current control. And we use these two technology to make the resilient and clean energy system. The first one is autonomous distributed control, and we put the software on every houses. And that distributed software manages the energy exchange between houses, and individual house has their own scenario to determine when and how much energy to buy or sell. And because it is distributed system, it avoids vulnerabilities or the weakness of the centralized system. And this makes the system very resilient against disasters. And next is active current control, the second key technology, active current control. All the excess energy stored to battery and exchange between houses. And the point is the system exchange certain amount of energy to requested locations. And this makes the flexible combination of energy sources and demands, and it doesn't rely on any like a big energy source or certain energy source. And this makes very flexible system, and it can make a renewable based energy system. And there is a remote monitoring system. The system is installed in Okinawa, and we are maintenance the system from Tokyo. So we implement some operation and maintenance system to check the status of the system and also manage the failure of the system. Sorry, and lastly, future plan. We believe that our target or the goal is also to contribute to the sustainable development goals, and our system can contribute to 7 SDGs. Yeah, and now there are the climate change and the power outage due to a disaster or the very severe disaster is becoming a very big problem in the world. And so now clean energy and the resilience energy system is a very key technology for the future energy system. And yeah, our system is operating in Okinawa, and it survived a very huge or very strong typhoon which hit the Okinawa, and we believe that this system is very good for clean energy and resilience. And now we are looking for the partners to make sustainable energy society together, and we are very open for the discussion about to make the new energy society. So I'm happy if you are interested in this system, please contact me and have a free discussion. Yeah, and that's it for me. Thank you.
Yeah, thank you so much for sharing, Daisuke-san.
Yeah.
And so, if possible, we will share your email address and contact with to the audience.
Okay.
And so, is it okay for us to share your contact with to the audience?
Yeah, I will later. I will inform the contact email.
Okay, sure. Thank you. And yes, thank you so much for your detailed information and the well-prepared movie for that. Yes, and there is also the friendly reminder again that if you have any questions to our speakers, just raise it in the QA box and we will go through the questions and send to the speakers. Thank you so much, Daisuke-san.
Thank you.
Thank you. So, and now later, we will have to, move on our next speaker session. Okay. Our next speaker, this is for the finance session, and our next speaker is Toru-san, Head Structured Finance of Goldman Sachs. And Taro-san runs the infrastructure and structured finance team in Goldman Sachs Tokyo office. He has taken a leader role in developing the world's first projects bounced back up by solar assets and in arranging Japan's first revenue bonds issued by Ibaraki Prefecture's waste management agency. And in today's presentation, Taro-san will talk about the growing importance of project bonds for Japan's solar industry. Hi, Taro-san. Yes, we will open your voice and I will share the slides for you. So just give me a signal when for the next page. And here is the presentation materials. Would that be okay for you?
Hello.
Yeah, hello.
Hi, Starry. Yeah. Yeah, it sounds good. When will my session start?
Yeah, you can start your presentation right now.
Right now? Okay, I thought it was 40.
We are like 10 minutes behind.
Okay, all right. Well, thank you, Starry. And hello, everybody. My name is Toru Inoue. I run the infrastructure and structured finance team in Japan for Goldman Sachs. I'm very, is it okay?
Yes, I will share your slides again. So can you see that right now?
Okay. Right. So I'm very honored to be part of this important event. And today, as Starry has kindly introduced, I would like to talk briefly about project bonds and why it's even more relevant today than when it was developed 7 years ago. Okay, so let me move on to that page. So project bonds for Japan's solar industry is a structure that we developed in 2013. The background for this, why we thought of developing this structure is that for years, we, Goldman Sachs, have been very aware of the pent-up demand among capital market investors to have direct exposure to infrastructure. That has not been readily available in Japan. So the capital markets investors who wanted to have direct exposure to infrastructure had to look for deals overseas. Now, we were very much aware that if we could find local deals, the capital markets would be very excited. Now, in 2012, when the Japanese government introduced the feed-in tariff for renewables, we saw that the renewable business and solar in particular would be expanding quickly, very rapidly. So we saw that it would make a lot of sense to connect this expanding business with the capital markets who have been waiting for an opportunity to have exposure to infrastructure and renewables. So that's where kind of we had this idea of developing a new structure. And in doing so, what we did was we thought that using an asset finance approach or utilizing an asset finance structure would make a lot of sense, because the renewable projects in Japan, we thought that they had certain characteristics that would lend well to an asset finance approach as opposed to a much more complex project. For instance, like oil rigs or building airports in Africa. Compared to those kind of projects, we thought that renewables in Japan would lend itself well to an asset finance approach. So what we did was that I think we were one of the very first, or if not the first, bank to bring in a GK-TK structure to Japan Solar. A GK-TK structure is, as many of you might know, is a structure that has been historically used for commercial real estate and aircraft. So it's an asset finance structure, but it's very good when used when you look at it in the sense that it expands the universe of investors. If you compare it with a traditional project finance setup where you have a handful of specialized commercial banks who have project finance units dealing with sponsors whom they have historical relationships. Traditional project finance is, the relationship does have a huge role to play. Whereas in asset finance, it becomes possible to connect a wider universe of sponsors to a wider universe of debt providers. So we thought that, well, on one hand, we have this huge capital markets ready for infrastructure and renewables. And then on the other hand, we have a quickly expanding business where you have new entrants, new faces, new types of companies, both from local sources and also from international, from abroad. So if we can come up with a structure that connects many people with many investors, then this might make a lot of sense. So that's where we started our project bonds in 2013. Now, I think this made a lot of sense. What is interesting is that this GKTK structure has since been adopted by many other banks as well. So that kind of validates that this view, this approach does make sense. So we're happy with the way the Japan market has expanded, and since 2013 we have been able to finance more than 20 power plants, and over the years the investor universe has grown steadily. We're seeing much more. What started as a handful of key investors has now expanded to a much wider universe where we have 30, 40 investors who have not only have either already invested in our deals or have contemplated investing or are interested in investing. If you include investors who are actively looking into our deals, it's the number is more closer to 50, I would think. Now, so that's all good, but on the other hand, if you look back the past 2 years or perhaps 3 years, we have experienced some hiccups, some road bumps, mainly due to confusion related to government policy, and more recently, obviously, the COVID-19 related disruptions. But in 2017, the government started tweaking the rules, the feed-in tariff rules, slightly. That was kind of a sign of things to come. And in 2018, we had some very serious changes in the rules, the frameworks. The government insisted that this is not a change per se. It's more like filling in the holes that was left when the rule was hastily assembled. But in any case, many participants, to many investors, to many lenders, it seemed like the government was backtracking on its promises. What looked like a project that had its economics locked in suddenly looked shaky or lost for some projects. So it was serious, and many people started lobbying and gathering among themselves, figuring out what to do and how to move forward. The general atmosphere was not too, was actually bad. We felt like there was a heavy cloud over the business, and what was more, we thought it seemed to us that the government's actions was, yes, partly their effort to improve what in their mind was an imperfect set of rules. You can understand that, but what was more worrying, at least at that time, was the fact that it might have been reflective of a general atmosphere or mood in Japan that was, to a certain extent, anti-solar. You would see newspaper articles, you would see media reports, magazine stories, talking about the end of solar, or people would criticize people in the solar industry for making too much money or taking advantage of the system, especially, and it was a lot of this criticism, at least from my perspective, was unfair. There was a lot of criticism towards international players who have been unfairly framed as kind of taking advantage of the Japanese system and making more money than they should at the expense of the Japanese taxpayers. And all this sentiment was worrisome because, one, it was unfair, at least from my perspective, but two, because it seemed to be so distant from the sentiment or the atmosphere globally. All over the world, people were so conscious about clean energy, renewables. Going forward, it seemed like Japan was really kind of isolated and lagging behind by years. So that was very worrisome. And actually, I had some discussions with investors who came to us and said that, well, we're not going to invest in, these are debt investors. We're not going to invest in solar anymore because they don't trust the government. Or we had some investors who said that, well, we're going to take a wait and see attitude until this kind of plays out, to see how this plays out. And we were getting really worried. Now, fast forward 2020, I think the mood has improved significantly. I believe there were other panelists in this event who touched upon Prime Minister Suga's most recent announcement, and that's very indicative of the change in mood. But the past 6 months, there has been repeated announcements from the ministry, from government officials that have sent a very different message, telling us that the government is now fully supportive of renewables and solar. So we're back on track. The solar industry has now recovered its activity. The COVID-19 related disruption has now been more or less taken care. It's been overcome. From what I see, investors who were shocked or shell shocked at the market disruption in March, April, May, they have recovered. So activity is back on track. So now, with the very increasing consciousness of ESG and green and sustainability, the project bond investors are more than ever looking at project bond deals. They're very hungry and anxious for more. However, I do hear from some of my sponsor clients that the commercial banks might be slowing down a little bit. Now, this I can only guess what the reason is, but I do hear from some sources that because solar lending has been concentrated heavily to a handful of banks in Japan, and this is outside our project bonds, their exposure to this sector might have become very large. So they're trying to control that. And I've also been told that the commercial banks, and probably because they still have this traditional lending philosophy in place, they have a single sponsor limit. So even though these are non-recourse, GKTK loans, there is a certain limit to the amount that they could lend to a project with a particular sponsor. So this might be another reason why there is a certain amount of slowdown. But in any case, the market is still very active, and the capital markets are very excited about these deals. Now, the next page talks about a deal that has won the J Money Best Structured Product 2019. It was a deal that has been closed in June 2019. This was arranged for a sponsor from Europe, Etrion, who is a major renewables player globally. They have a number of deals in Japan. We arranged for them a project bond that was roughly 16 billion yen. It was the biggest deal, biggest project bond deal as of the time. It was rated triple B. It had a coupon of 1.2%, was rated triple B by RNI. Now, it was a wonderful deal, but one of the interesting aspects of this deal was that I'll be careful in saying this, but the credit quality of the EPC at that time was not triple B. It was a wonderful EPC with global experience, very large company, but it was encountering some credit issues, so it was not investment grade at that time. But we built in enhancements. We built in a monitoring process done by the backup asset manager. The backup asset manager had a double hat of construction monitoring agent. So to make sure that if in the very rare instance that we needed to replace the EPC, all the documents and all the stuff that needs to ensure a smooth transition would be in place. So in addition to certain reserves and other enhancements, we were able to not have the corporate credit of the EPC become a cap on the overall rating of the bond. So the bonds were rated triple B, even though the EPC was not necessarily triple B. So that was one interesting aspect of this deal. But overall, this is indicative of project bond deal where we have on one hand a very international sponsor, and on the other hand the capital markets investors. So our initial goal to connect a wide array of sponsors to a wide array of debt investors is very much visible in this transaction. I believe I have used my initial 15 plus minutes to do my presentation, and I'm ready to take questions if there are any.
Okay, thank you so much for your presentation, Taro-san. Yes, we have one question for you, and it is from the audience. And so, what do you want to ask that? So, is there any other like financing models that you are trying to reaching out or looking for? That is the ways maybe will change the Japan renewables financing environment or somewhere else.
Can you? I'm sorry. Can you repeat that question?
Yeah. Okay, yeah, sure. So do you think there is any other like financing models you are trying to reaching out or looking at that could change the current situation or would like to improve better for the Japan renewable energy market?
Well, I'm not quite sure if this is relevant to this event, but we are also working on applying this structure to wind farms and biomass projects. So we're making some tweaks to the structure to adapt to the different risk characteristics of these different asset classes. But the concept of connecting a wide array of sponsors to a wide array of debt investors is still there. So we're trying to apply that concept to other renewable projects, if that answers your question.
Yeah, I think so. And thank you so much. Mm-hmm. And so I think, yeah, there is like one more question is that when would you recommend like bond financing or versus the traditional non-source project finance?
Well, I mean, that's a great question, and the answer is not that straightforward. But one, as I keep saying this, the traditional the traditional commercial bank loans are relationship driven to a certain extent or to a huge extent. So if you have the relationship in place, bank financing, if you have a very strong relationship that you can rely upon, then a bank financing can be very competitive. But if you're relatively new to this market and you don't have the historical relationship with the local banks, or if you're trying to limit your exposure to your relationship bank, meaning that I've mentioned a little bit about the single sponsor limit. If you don't want to eat up too much of your relationship capital, if you will, with your banks, and you want to go true non-recourse, then a bond financing is much more true non-recourse, and the relationship capital, if you will not be used or exhausted.
And because we still have like 5 more minutes like planned for your presentation, so we have received many questions in this Q&A box. So I will like yeah, if you have time, you can type to answer some of them, and I will like select one more for you to answer.
Well, I don't think I can see them, so well, hold on. Can I?
Yes, it's in the QA box.
Oh, here we go. All right.
Yeah,
so
you can see there is some questions.
How should I do this?
There is type answer. You can type to answer. You can choose one to answer live.
Okay, well, let me start from the top one. Is that okay? So you have, could this structure work for a portfolio of small projects? Well, very small projects, right? Well, potentially yes. We have been looking at this type of deal. I can't say that I have done one the exact type of this already, but we have been actively looking into it, and we have looked at certain legal aspects, and I think it is actually doable. So should I go to the next one?
And this one have already answered. And
Oh,
yes,
right,
I think
right.
there is time for one more questions. Yes, there time for one more questions. So, how about have you taken the project complication risk? In other words, the FIT reduction risk for the latest METI one-year rules projects in the fund financing?
Well, the answer is that no, not in a straightforward way, meaning that we have been looking at this one-year rule deals, and what we have done is that we have created a holdback reserve, which is not released until the one-year rule risk goes away. So yeah, we have financed one-year rule deals or about to yeah, we have been looking, we have a structure for one-year rule deals, but it utilizes a holdback reserve, so it might not be taking on that risk directly.
Sure. Yes. So because we will have some time to move on our next session, and you can type answer the other questions from Motohisa-san for you.
So you're saying that I can kind of answer this?
Yes, you can just type to answer it.
Right. So all right. So I'll do it.
Yes.
I'll answer it afterwards.
Yes, you can stay in this room and answer the questions from the audience.
Okay, sounds good.
Thank you so much for your presentation and your detailed explanations for the previous questions. Thank you so much.
My pleasure. Thank you.
Thank you. And so next we will move on to our next speakers in this finance session. And so let me introduce the speakers. And the next speaker of this session is Mr. Chris, client analyst APAC from Restart Energy, and Dr. Ming, senior research analyst APAC from Restart Energy. And Chris is responsible for working with the clients on a day-to-day basis with analysis, methodology, and data requests. He is also assessed in the relevant consulting projects. And Dr. Ming is responsible for the research and analytics of APAC renewable energy, with a focus on the East Asia specifically. And Chris will give us a presentation today, and Ming will responsible for answering all the Q&A questions in the QA box. So please feel free to raise questions in the QA box. So Ming will handle all of them. So Chris, would you please share your screen and begin your presentation?
Yes, thank you very much. Sorry.
Thank you.
Mina様、こんにちは。ライスターエネジーのクリスと申します。外国の方もいらっしゃると思いますので、皆様がお分かりになりますように、英語でご説明させていただきたいと思っております。Hello everyone, my name's Chris. I'm with Rystad Energy, and I hope you have enjoyed today's conference so far. And I would like you to bear with me for the last presentation of the day, where I'll be talking about the current state of Japan's solar auction and how it's affected the market. So just before I begin, I'd like to do a little introduction on Rystad Energy. We are a global independent company providing data, reports, and consultancy. And we are a Norwegian company, so our headquarters are in Oslo. But within APAC, our headquarters are in in Singapore. And I'm speaking to you from our Tokyo office today. So what do we cover? Well, we cover the entire energy industry, all the way from oil and gas to the energy transition. But today I'll be focusing on the renewables and power market And within there, I'll be looking at solar, of course. And then what do we provide? Well, as I mentioned, we provide a database and reports. And within there, we have information on projects such as ownership, development stage, capacity for solar projects, the panel manufacturer. If it's wind, it's the turbine manufacturer, location, as well as covering, you know, what kind of energy source. So is it solar? Is it wind? Is it storage? And then we also have economic information for these projects. So we have, you know, project cost, investments, cost evaluation, free cash flow, and project profitability. And we do this for all projects around the globe. So on this map, you can see all the projects that we cover. And the brown projects, those are currently operating projects. And then the blues and the greens, those are future projects. And then the size of these bubbles represents the capacity. So as you can see, the brown currently operating projects are much smaller, and then those future projects are larger, representing how project capacity size will increase. That's me on the right. As I mentioned, I'm based in Tokyo, as well as my colleague Yosuke Uhara. And then on the left is my colleague in Sydney, that's Dr. Min Koi Lee. As Starry mentioned, he is here live and he is answering questions in the Q&A. So if you have a question while I'm presenting, please type it in and he will respond to you. And just a little background on him, he's our senior renewables analyst and he's covering the Asia market. So today I'd like to begin with a bit of a backstory on the Japanese PV market. And then I'm gonna look towards briefly some of the challenges that are faced in Japan. A lot of them have already been mentioned today. And then I will take some time to look at how the Japanese auctions have worked and then compare that to some examples abroad. And then finally, I will look towards 2050. So starting with the background, just as we begin, all the projects that we cover are projects above 1 megawatt capacity. So those are utility and larger scale projects. We don't cover the residential projects. But if we look at the Japan solar PV market, on this graph, we can see the amount of capacity installed each year. So we can see the beginning of this FIT at the market really due to the FIT scheme. And you can see how much that there was a large amount of investment and projects introduced during this period. And now we're in this auctions period, which has seen a bit slower growth. And that's probably due to the feed-in tariff price, which has gradually decreased over the last 8 or 7 years. And then looking ahead past 2021 and 2022 is this new feed-in premium or FIP structure that the government has announced. And I think some of the other panelists spoke about this this morning. So on a global level, we can see how CapEx for both wind and solar has been decreasing. And especially if we look at solar in orange here, you can see how CapEx has decreased quite rapidly over the last 5 years, which should be very beneficial for everyone in the market. However, if we look at Japan's levelized cost of electricity compared to other mature markets, and this is just for solar, utility solar, you can see that the price is still stubbornly high compared to other markets. So what are some of the challenges that are facing the market in Japan? These have been touched on today by other presenters, but one is the difficulty obtaining land rights in Japan. And in there I include ex-agricultural land and ex-farmland, which could be used for solar farms, but it's quite difficult to get the rights to do that. And of course, Japan is a very mountainous country, so there's little space to actually develop renewable projects, and that's why some of these projects are now being developed on mountains. Compared to other countries, there's quite strict regulations, and that also includes a high cost of connection to the grid. There is a lack of grid availability, in part that is due to the 2-frequency system that is in place in Japan, but also those kind of smaller regional systems. Japanese labor is, of course, very high quality, but that comes with a higher cost as well in general. So there's high construction costs. And then finally, we have this buildup of paper projects. And this is essentially projects that have got approval during the FIT scheme. So they have a high FIT price, but they haven't started operating yet because they're waiting for costs to decrease. So if I look at solar PV pipeline in Japan, again, we have this brown. This represents the currently operating projects. Again, I mentioned this is above 1 megawatt project, so more large scale. So brown is operating, yellow, this shows under construction currently. And then this green is DA approved, which means they have approval from the government. And in here, this is where we have a lot of these paper projects that are waiting for prices to decrease and are basically in limbo currently. Of course, that's not all of them, but it's some. And if we look at the top 15 solar companies based on capacity, again, this is above 1 megawatt. You can see a lot of these companies also have a lot of green in their pipeline, which suggests a lot of these projects came from the FIT era and they are yet to be operating. Now I'd like to take a little look at Japan's auctions so far and compare that to a few case studies around the world. So on this graph, on the x-axis, we have the 5 auctions that have been held so far. This dark green, this is the awarded capacity in these auctions. And this light green, this is the unawarded capacity based on the targets set by the government. This red line, this is the average bid price. And this dark red line, this is the lowest bid price. And finally, this black line is the ceiling price. So we look at the first auction in 2017. You can see it wasn't that successful. There was only 28% of the capacity awarded. And actually, some of those projects didn't pay their second deposit. So actually, that number could decrease even lower. And if we look again now to the second auction in 2018, in actual fact, there was no capacity awarded in this auction. And we can see the reason why. The lowest bid here was actually higher than the ceiling price. So this is potentially an issue in Japan because the government does not tell you the ceiling price. So companies don't know, what price to bid essentially. However, if we look now to the third auction, which happened a few months later, you can see it was a very, very successful auction because 100% of the capacity was awarded. And the main reason for this could be the fact that the ceiling price was the same as in the second auction. So this gave developers an idea of what price they should be bidding in order to get their projects to be awarded. So then after the third auction, the minimum project size was reduced from 2 megawatts to 500 kilowatts. And you could see that had a positive effect on the auction because the fourth auction in 2019 was fairly successful. It had 65% awarded and a very low lowest bid price as well. So a lot of these kind of smaller projects below 500 kilowatts were introduced here. But now if you look to 2020 and the most recent auction, it again wasn't so successful. There was only 10% awarded, and this could be attributed to land rights issues that we mentioned before, as well as limited grid availability. So how does these auctions, how has this affected the project size in Japan? So on the x-axis here, we have the capacity, the project capacity size in different groups. And then on the y-axis, we have all the capacity which is included in those different groups. So you can see here that the majority of the projects in Japan are between 1 to 3 megawatt in capacity size. So the market in general, as well as some of the issues like land issue, space issues, this kind of favors smaller projects in Japan. And if we compare that to the rest of the world, you can see that in general, in other countries, the projects are above 30 megawatts. And in fact, I have cut the graph here, but there's actually even larger projects in some countries as well. And how does that affect the pricing? Well, if we look at this graph, we can see on the y-axis, the PPA price for solar PV, on the x-axis, the construction date, and then the size of this bubble represents capacity again. So we can see Japan in this dark green up here. In this medium green, we see Asia and APAC. And in this light green, we see the rest of the world. And basically, we can see that Japan's PPA prices are still higher than APAC and much higher than some other countries around the world. And we can kind of see that the prices, although they are decreasing, they're quite similar to prices that happened in Asia maybe 5 years ago. So in the price reduction, you can see that Japan's about 5 years behind some other APAC countries. Additionally, what's interesting to see here is that the larger projects seem to be much, much cheaper because they have the economy of scale on their side. So these larger projects have much cheaper PPA price. And as we know, Japan has these smaller projects. So in general, these PPA prices are higher. So let's look at some other case studies around the world. First of all, we will look at how policy changes can affect the market. So this is the same graph I showed you at the start. In the green, it has the amount of capacity introduced each year for the solar PV market in Japan. And in red, I have added the same for Spain. So if we focus on the Spanish market first, you can see from 2008, we had this early boom. And actually in 2008, that was the world record for PV installation. And this was due to, Spain had very early innovative policies, as well as they have very good solar resources as a very hot country. And again, they have a stable economy. So that led to, confidence in investors, but they also had this generous FIT system, which again, encouraged people to apply and go for projects. However, if we look after 2014, there's a period of slow growth. This was due to the financial crisis in 2014, also the downside of the generous FIT, because suddenly the market was flooded with a lot of capacity and it became very competitive quickly. But also there was kind of outdated policies by the government, which actually prevented utilities from gaining true costs. And this created a financial deficit. So the companies were essentially losing money. So in order to prevent that, the government changed some of the policies, but obviously that decreased investor confidence because they were retroactively changing these policies. However, if we look from 2019, there's been a large comeback in the solar market in Spain. And this is due to new auctions, as well as generally reduced cost in solar. Also, there's corporate PPAs, which has been mentioned by other presenters today. And this has helped it become a more sustainable market. So these new policies gave way for a more sustainable market that doesn't need government incentive. So now let's compare that to Japan in green. Again, we can see an initial boom based off a generous FIT scheme. Then looking a few years down the line, we have another section of slow growth. And again, this was due to one, decreasing FIT prices, but also the issues we mentioned earlier, such as land and connectivity issues. Also the government, retroactively changing some policies in order to try and clear these paper projects we spoke about. So what does this mean going forward? Well, it means that just like in Spain, if the government does good policies, basically there can be a large revival in the solar market. And this is important looking towards 2050. Another case study is Colombia, which is now looking at auction design changes. So Colombia had their first renewable auction in February 2019, and with a target of 500 megawatt capacity. Actually, there was nothing that was awarded. Again, the auction was not held, and this was due to, first of all, some antitrust rules. So they wanted to prevent the larger companies in Colombia basically getting all of the projects because they wanted to promote competitiveness. But unfortunately, these antitrust rules, actually these companies could bid on both the sell and the buy side. So essentially the larger companies could do both, and they could see the general bidding selling prices, so they could adjust their bidding prices. So only a few companies have got a lot of the tenders. So basically the government decided not to hold the auction. It was also oversubscribed by 3 times, and also they had short PPA contracts of about 12 years. However, later the same year, they held their second auction for both wind and solar, and it was very successful this time. So what changed? Well, one thing, they changed the PPA contract length to 15 years. Again, that's not relevant to Japan because Japan already has 20-year contracts. But they did introduce a 10% minimum renewable quota on distributors. So basically, these utility companies had to distribute 10% of their electricity that comes from renewable sources. Again, there was a reduction in the minimum capacity size. We've seen this in Japan as well. But finally, they looked to their neighbors in Chile and they adopted their block structure. So in Chile, they have 3 bidding blocks, morning, day, and nighttime. And basically this allows developers to make compatible bids that fit their generation curves. So it's much more attractive. So what are the future incentives for Japan, and what are potential ways to revitalize the market? Well, one is corporate PPAs that we've spoken about, and other presenters have also talked about today. We could have an FIP system, which essentially has a changing premium based on the market price. But if you have a cap, this doesn't make the premium too high, so it stops high prices for end consumers. And if you have a floor, it doesn't have a premium which is too low, which protects the project profitability. You could have regional FIPs that works in Italy. Essentially, they change the premium depending on different regional supply and demand. And that could work well in Japan because of the nature of how things change so much in Japan, depending on the region. And if the government make reliable policies to ensure long-term sustainable growth, eventually, maybe through the FIP system, the market will go from needing government incentives to a sustainable market. Finally, they could try some different auction designs. So one in Chile is a second round bid. So if you bid above the ceiling price, essentially there's a second round and gives you a second chance to make a bid. Or in Brazil, for example, you could look at the descending clocks bid we have on the right. So the initial winning bid, after that, there's 5 minutes for other companies to try to outbid or bid lower. So it's very aggressive. And then there's a new bid, winning bid. And then again, there's a third round, and then there's a third winning bid, and it keeps going down until it kind of hits a floor. Or the government could disclose the auction price to make things more transparent. So I'm just going to finish up by looking towards 2050. Prime Minister Suga obviously 2 days ago mentioned a decarbonized 2050 decarbonized society. So how can solar play a role to get there? So currently on the screen is the utility PV, which is operating or already approved. Then if we add on top of that, the currently installed residential and small scale capacity up to 2040, we can see how much new solar is needed to get to the 2040 targets. And then to a 2050 decarbonized society, you can see there is a lot of demand for new solar. Another kind of side effect of having a decarbonized society is traditional oil and gas companies will start investing into the renewable market. And maybe a lot of people here today don't want to hear about oil and gas companies, but if you look at this map, you can see that oil and gas companies are already, especially big ones, are already investing in mature markets around the world, like America, India, Australia. They are still quite small in Japan. But this is actually a good thing. Apart from increasing competitiveness, these larger oil and gas companies will invest in new technologies like storage. They will invest in smaller developers to help them bring new projects in. And they will also bring in larger capacity projects. And all of this can help push towards a decarbonized society in 2050. And they will be coming because basically renewables can now compete with oil and gas on price. There is, of course, global pressure, especially after COVID-19. Tech companies are now moving to RE100, so they don't accept traditional energy sources. There is less risk than oil and gas. There is less capital needed than oil and gas. And maybe it's very clear here to see, but the stock market is also pushing companies this way. So Ørsted is used to be a Danish oil and gas company, but they changed to renewables in 2016. And you can see how their stock price is increasing compared to BP, which hasn't increased over the last 5 years. So finally, what does Japan's energy mix look like with this new decarbonized society? So we looked towards 2040, and you can see these, first of all, coal in gray. The government is going to start decommissioning a lot of these inefficient coal plants. So that will decrease coal's contribution. Gas as well, there'll be increased gas prices going forward, or we forecast increased gas prices. And also the government wants to move away from fossil fuels and dependence on foreign importers. So that will decrease. In the orange at the bottom, this is nuclear. We believe that the local opposition will prevent nuclear from really coming back in a strong way. So all this means there's a lot of room for renewables to develop. So in the yellow, we see this is solar. We can see it growing year on year to 2040, as well as interesting offshore wind in the orange here. We forecast to grow due to the high resource potential and chance to make large capacity projects. So that's the end of my presentation. Thank you all for listening. And I hope you had a good day at the conference.
Yes, everything is okay. And thank you so much for your presentation, Chris. And also thank you a lot for Ming's answers in the QA box. So, Dr. Ming, would you like to add something else regarding the questions you answered?
No, I think all the questions coming in is very good. So if anyone would like to have actually more information on what we talked about in both the presentation and in the box, you can always send us email and we can provide the background of what we presented here today, the background of our research and so on, as well as our view in the market in a little bit more details in terms of pricing and all that. You know, I'm not sure with the recording of the session, if this Q&A will be recorded as well. But if not, we can just talk about some of these out loud. So Starry, do you know if the Q&A will be also recorded?
And the Q&A, we will select some really good questions and add them in our procedure report.
Okay, great.
And so, anything else you wanted to add? No.
No, I think that's thank you, Chris, for the great presentation. And yeah, as Chris mentioned, we have the office in Tokyo. Chris is based in Tokyo as well, so we will always be happy to get a meeting with you if you want.
Thank you so much. Thank you for it too.
Thank you,
And
Starry.
so, thank you. And so next, we will, as we have finished all the sections of today, and we already come to the end of the third Japan Solar Plus Energy Storage. And I will here to express our grateful thankfulness to all our speakers, valuable speeches, and your patience for staying by in the rooms. And wish you all have enjoyed the knowledge contribution. And also many thanks for our attendees and staying with us during these 2 days. Before we end today's conference, I would like also to introduce we have another co-located event. It is Japan Wind Energy, and it will begin tomorrow morning at 10 a.m. So hope you all can join tomorrow as well. And with the aim of accelerating the green transition, more and more digital contacts will be created by leader associates continuously, and keep enabling the business network and insight sharing. Last but not least, we will hold the 4th Japan Solar Plus Energy Storage Conference next year in Tokyo, Japan. Really wish that everything can go on well, and wish to meet you all physically in Japan. So see you tomorrow in our tomorrow's second Japan Wind Energy Virtual. And thank you so much for joining.